Hi guys, it's Miss Davis. Today for chemistry we're going to be talking about reactions and balancing equations. This kind of has something to do with your percent reactions, basically just kind of getting you into that mindset of using math a little bit more in chemistry. So your bell work today is what is wrong with the following equation. If you have H2, which is hydrogen gas, plus O2, which is oxygen gas, and that gives you H2O, which we know is water. So take a second, see if you can identify what's wrong with it, pause the video. When you get done, go ahead and hit play and see if you got it right. So hopefully you saw that if we have two hydrogens and we have two oxygens, over when it makes the H2O, over on what we call the product side, we have two hydrogens still, but now we only have one oxygen. So remember that would be a subscript of 1 there. So the thing that's wrong with this is that it's not balanced. It's not the same on each side. You want to have the same amount on one side as you do on the other. So that's basically what we're talking about today. Your essential question, how do I determine if the chemical equation in a reaction is correct? Again, if you have the same number of atoms on the left side or on the reactant side as you do on the right side, then it's good to go. If you do not have that, then you know your equation is wrong, and that's what we're doing today. Is we're going to make them better. We're going to fix them. All right, so intro to chemical equations. Anytime you have a formula, we also call that the chemical equation. It's kind of like math class, so that if you have x plus y will give you xy. Okay, so this right here is going to be your equation. It shows the reaction between the substances. We'll get more into chemical reactions next time, so be ready for that, but there's 4-ish different types of reactions that you can see. Reactants, they don't always go on the left side. More often than not they will be, but sometimes they go on the right. It just kind of depends. However, the arrow will always point to the product. Okay, the arrow will always point to the product. So the reactants, these are kind of like your ingredients. So if you have, if you're trying to make a cake, and your reactants would be things like your flour, your eggs, your sugar. The product is going to be the final outcome. It's going to be the actual cake. It's going to be the cake with the frosting. So the reactants are what goes into it. The products are what comes out. Okay. So you do not necessarily need to write the picture down. This is just showing you that if you take ammonia, which is NH3, plus your hydrochloric acid, you get NH4Cl. So you still have the same atoms on each side. You still have the same elements. It's just a matter of combining them and again making sure that everything is balanced. Okay, so what I want you to do now is in each of the following equations, determine which is the product and which is the reactant. I do want you to do these in your notebook. I want you to practice these. Pause the video. Let me put these up here. Pause the video, try these out, and when you get done, check your answers. Alright, so checking our answers. Iron plus oxygen, that's going to be your reactant. The arrow is pointing to the product. Okay, the second one's a little bit different because the arrow is pointing to the product. The product is actually on the left, reactant is going to be on the right. And then finally, again, arrow points to the product, reactant is on the left. Alright, so when you are doing a chemical equation, you need to start with what's called a skeleton equation. It will tell you the reaction without telling you amounts. So it's kind of like saying, again, if you're baking a cake, it says you need flour, sugar, eggs, some water, but it doesn't tell you how much flour, how much sugar, how many eggs. It's just a general outline. Okay. Some equations, this is just kind of a side note, they will use what's called a catalyst to speed up the reaction. The catalyst does not affect the product of the reaction. It doesn't actually get put into the final outcome. So again, another example, I guess if you look at the picture here with the turtle, the turtle is going to move either way. Okay, the turtle's gonna crawl very slowly on its own. If you think of the little rocket attached to its back, if you think of that as the catalyst, again, it doesn't affect the turtle, because we're not going to blow the rocket up, but it doesn't affect the turtle, it just makes him move faster. So he's going to get from point A to point B very quickly as opposed to very slowly. Another example of a catalyst would be like if we go back to baking a cake, if you turn your oven up higher, that's technically a catalyst. You're still going from your ingredients to your cake, you're just trying to get it done a little bit faster. You do need to put these into your notebook and you need to study them because these are the symbols that we're going to use in our chemical formulas and our equations. If you have a plus sign, that is what separates reactants and I guess 2 or more reactants and 2 or more products. So again, if we have like H2 plus O2 gives us H2O, this plus sign is telling you that you have hydrogen gas and oxygen gas. You have 2 different compounds there. The arrow, when it's pointing in a certain direction, that's going to mean yield. However, it's the exact same thing as an equal sign. So if you have hydrogen gas plus oxygen gas equals or yields H2O or water. Okay. Sometimes you'll see something that looks a little bit like this. So you have 2 arrows, one's pointing to the left, one's pointing to the right. That means that the reaction's going to consistently go back and forth. So under the correct conditions, you can have what's called electrolysis. You can take this hydrogen gas plus oxygen gas, send it through electrolysis and get water, but you send that water through electrolysis and it'll give you the gases back. So it's just kind of like a cycle. If it's in parentheses, that's going to mean solid, liquid, or gas, so S, L, or G. So, and then AQ means it's aqueous, which means that the substance is dissolved in water. So if you have an aqueous solution of sodium chloride, that just means you have salt water. If you have an arrow with heat above it, that just means you supplied heat to it. And then if you have some sort of formula or an element written above the arrow, that means that this is the catalyst. So again, you get that back at the end because it's not actually part of the equation, it's just there to speed it up. Alright, so now we're going to talk more about balancing these chemical equations. You have to think of these as kind of like a teeter-totter or a seesaw. If you have 5 hydrogens on the left side, you need to have 5 hydrogens on the right side. You have to have the same amount, okay? Otherwise your teeter-totter will be off. So because those skeleton equations don't show you the correct number of substances, we're going to use what are called coefficients, and those are going to be big numbers that sat out in front of the compound or the element. So instead of having something like H2, where this is the subscript, if you have 2 H2, that's this right here is the coefficient. It's a big number. Okay, so this is the subscript. This is the coefficient. The coefficient you can kind of think of like the distributive property. So if you have something like H2O, okay, and let's say we have 3 of those, you're going to distributive property that 3 to both elements. So what this means using the coefficient is that you actually have a grand total of 6 hydrogens and you have a grand total of 3 oxygens. Okay, so distributive property, you got to give it to all of those elements. So another way to look at this, without thinking of chemistry, you can kind of think of it like doing something more real world. If you have a bicycle frame plus wheels plus handlebar plus pedal, gives you a bicycle. Okay, but it doesn't tell you how many. All right. So taking our skeleton equation, which would be this one, so our top is our skeleton equation, we need to fill in with coefficients. So I want you to pause the video. I want you to go ahead and try to solve. So how many frames does it take? How many wheels? How many handlebars? How many pedals? And how many bicycles would you get out of this whole thing? So pause the video, try it, come back when you're ready. So hopefully you got that you have one frame, two wheels, technically one handlebar if you think of it as one piece. If you have two there, that's fine. And then you need two pedals, and that will give you one bicycle. This right here, this is your balanced equation because you're using coefficients and you technically have the same amount on each side. Okay, so here's your steps to balancing the chemical equations. Step one is you just write the skeleton equation. Just make sure you leave room for the coefficients. You're going to write your substances on both the left and the right of the yield sign. And then you use the coefficients to balance the equation. Don't forget your law of conservation of mass. So if you have 10 hydrogens on the left, you need to have 10 hydrogens on the right. You can't just lose them. We can't get rid of stuff because physics and chemistry say we can't do that. So we're going to practice some of these. So we'll do this first one together, and then we will, then I will have you try some on your own. Alright, so if we have H2 plus O2 equals H2O2, there's a pretty easy way you can do this. Oh, hold on guys, I've got a crying baby. Alright, so on the left side, you're going to put your two individual elements. Same elements are on the right side. On the left side, we've got two hydrogens, so we're going to put a 2 next to our H. We've got two oxygens. And then we actually have the same. So as you go through it, you're going to see that 2 and 2, 2 and 2. This equation is actually already balanced. So let's do Al plus O2 yields Al2O3. So again, we're going to write our elements, Al and O. On this side, we've got 1 aluminum and 2 oxygens. On the right side, we've got 2 aluminum and 3 oxygens. So, easiest way to kind of go about this is you're trying to see least common multiple of 3 and 2. So it's similar to what we've done before with our reactions. So if we have 3 oxygens and 2 oxygens, the least common multiple that they have in common is going to be 6. So 3 times what is equal to 6? So we're going to use our coefficient of 2. Okay, so 2 times 3, we now have 6. 2 times 2, we now have 4. Oh. Okay, same thing over here. So now we need to have it equal to 6. So O2, we're going to use a coefficient of 3. Now we have 4 for aluminum on our product side, so we need to give it a coefficient of 4 on the reactant side. All of our numbers match up, so now this equation is balanced. So overall it's 4 aluminum plus 3 oxygen yields 2 aluminum oxide. I'm actually going to pause the video here, mainly because I'm running out of time, and so I will pick it up with the second video here in just a second. So go to the second video, and we'll pick up on this slide.